Welcome to class number 28. In this class we will discuss about concept called port channel. So let's see the topology for this class. So we have R1 and R2. So let's assume that R1 is in one location. Let's say it is in London and this is in New York. So there is a whole network behind R1 in this London location. So here we are only just using PC1, but in real-time scenario you have whole office network. Similarly, behind New York office, you also behind the R2 you have whole New York office network. So R1 and R2 are the core networks that are connecting these two branches offices. So usually so far we have done using a single cable. So let's see, we just used the Ethernet one and we assigned the IPs like this. So all the traffic from London office will go to the New York and from there to the New York office machines. So what if this physical link goes down? Both offices will be isolated. So normally physical links can go down at any time due to the damage on the physical infrastructure, or it could be like ports going into a shutdown state, or whatever the reason. If this Ethernet one link goes down, it will be a huge impact because London and New York offices, they cannot communicate to each other. So if you would like to add redundancy into this topology by having another link, you can connect another cable, Ethernet 2 to Ethernet 2. But so without port channel, what you have to do is you have to assign IPs here as well, and then you need to put two static routes, normally one preferred with this way and another with lower preference this way. You can do that, but the other way to do it is using the port channel. Port channel is nothing but it will bundle these two physical interfaces as a one logical interface. So when you create a port channel, you just bundle the two individual interfaces. So on the R1 side, ETH1 and ETH2 will be acting as one logical port channel. So the properties, whatever you can assign it to Ethernet 1 and 2, you can just assign it to the logical port channel interface. So those properties will be applied to these two. Okay. So in this case, if we bundle these two ports on here, this side, and we create a port channels, R1 and R2 will use a protocol called LACP, Link Aggregation Control Protocol, to exchange information that they are using these two interfaces as a one logical interface. Once they agreed on that, they can use these two physical links as a one logical link. Okay, and the traffic will be flowed similar to how it flows in the normal physical interface. So port channel is a concept used for to redundant physical connectivity. So let's see how we can configure it. So there are two ways to configure the port channel. So one way is you create the port channel interface, you create a description, and for the port channel you can use it as a layer 2 or layer 3. In this example we are using a layer 3, so that's fine. I'm using no switch port, I'm giving the IP address. Then I will add the interfaces to the port channel. So I'm going to the interface Ethernet 1 and I am mentioning the channel group ID. So what is this group ID is, on a single device you can have multiple port channels. So for this example we are only have one, so that's why I'm just taking one. But if you want to like have another port channel to a different router, so you should give a different ID. Here you will take two. Okay. So in this example we are taking channel group ID as 1 and mode is active. Okay. So this mode should be 1 and it should be active for sure. If you have active on the both ends, that's fine. Both ends means this side and this side. Okay. So yeah, you can put active on both ends, but you should put active at least on one end, passive on another end. Okay. So next we are adding the Ethernet 2 to the port channel 1. Okay, so this is one way. First you create the port channel, second you will assign interfaces to it. Another way is you first create the port channel using this command under the interface. So once you do this command, automatically it will create port channel 1, but then you have to do the remaining rest of the configuration. Either way works. Okay, so we did the same configuration on the R2. So port channel 1 group ID should match between these interfaces, so that when they using the link aggregation control protocol, it works. So if you use different IDs on the both ends, it will not work. Okay, so you should use the same ID. So then once you have the port channel, you will assign the IP. Okay, so now let's verify the port channel status. The command to verify the port channel status is show port channel summary. So under the summary, you will see all the port channels. So in this example, we only have one port channel 1, and the status is in use, means it's up and running. And the protocol it is currently using is LACP. So the another way is the static method, but LACP is the best and advanced method. So ports Ethernet 1, you can see it has a status uppercase P, G, and a plus symbol. So let's see what that stands for. Uppercase P stands for bundled in port channel, means it is part of the port channel. G, uppercase G, it is aggregable, means this interface is supporting the aggregation, means it can part of the bundle. And the plus symbol is in use, means it's working fine, up. Okay, in sync means it was able to exchange with the packets with the other interface. Okay, so when you have PG plus, means it is in the current good state, working state. So you can see the same state for all of the interfaces. On the R2 as well, you will see the same status. Okay, so if you see any different status, you should check what is the flag is, and then you can troubleshoot further. So if you want to check the LACP statistics, you can use the show LACP neighbor. So each switch will have a MAC address. So this is not like interface MAC address, this is like a switch whole MAC address. Okay, so using the LACP protocol, switches or devices will exchange the information about the ports and their device MAC addresses and the neighbor status. If you see, we are asking R1 to show what are the LACP neighbors. So it is stating that it has Ethernet 1 and 2 connecting to this switch MAC address. So if you verify, it is matching with the R2. Same, when we ask R2 like what are the LACP neighbors currently you have, it is showing this MAC address, and this is R1's. Okay, so LACP will be, packets will be exchanged between the R1 and R2 to make port channel work. So now let's test the port channel. So to create a scenario where Ethernet 1 goes down in this topology, I'm just doing a admin shutdown. So I'm going to the interface Ethernet 1 and I'm shutting down. Then if you verify the show port channel summary, you will see Ethernet 1 is in D, down state. Okay, so it went down because the admin interface state is down. So now the only working interface in this port channel is Ethernet 2. So now if you try to ping automatically will go through Ethernet 2. Okay, so this is the physical redundancy we are creating using the port channel concept. Assignment for this lab is create similar simple topology and verify the port channel status and the ping connectivity when one of the interfaces is in down state. So verify the port channel status on the both devices when one of the interfaces is down. Yeah, that's all for this class. Thank you.